This video is on the zero product property. The prerequisite skills that you will need is good factoring skills. The zero product property is used to determine where a quadratic equation crosses the x-axis, or where y would equal 0. Example number 1 is y equals 3p squared minus 2p minus 5. Like stated before, we are trying to find when y equals 0, or where it crosses the x-axis. So if I want to find when y equals 0, I'm going to substitute in a 0 for y. Now I'm going to use the factoring method to be able to determine what my zeros are. So now we're going to factor this. Remember, we take a times c, which gives me negative 15, and I'm going to multiply to that and add to negative 2. So then my factors of 15 are either 1 and 15 or 3 and 5. So I'm going to put in 3 and 5, and the 5 is going to have to be negative in order for it to add up to a negative 2. So now I can either factor by grouping or factor using the reverse area model. I'm going to factor by grouping, so I'm going to keep my 0 equals 3p squared plus 3p minus 5p minus 5. As a reminder, the middle terms come from 3 and negative 5. Then I'm going to go ahead and group them. And when there's a negative, you put a plus sign between them. So now I'm going to determine what the first set has alike, what 3p squared and 3p has alike. 3p squared and 3p have a 3p in common. So if I divide out a 3p, I'm left with a p, and then 3p divided by 3p divided by 3p is 1. Then my next one, I have a negative 5p minus 5. They have a negative 5 in common, so I'm going to go minus 5. And then if I take negative 5p divided by negative 5, I get a positive p, and a negative 5 divided by negative 5, I get a positive 1. As a reminder, you want to make sure what's in parentheses is the same. So we have a p plus 1 and a p plus 1. That's what you want to happen. So now what you do is you divide out that p plus 1, and what you're left with is the 3p minus 5. And that all equals 0. What we need to remember is anytime you multiply anything by 0, the answer comes up to 0. With that being said, what you end up having to do is to take each factor, making it equal to 0. So we're going to take p plus 1 and make it equal to 0. And 3p minus 5 equal to 0. Now we are going to solve both of these equations. So I'm going to subtract 1 from both sides, so I get p equals negative 1. I'm going to add 5 to both sides of this equation, so I get 3p equals 5, and then I'm going to divide by 3, so I get p equals 5 thirds. So my two answers are p equals 5 thirds and p equals negative 1. What would end up happening is if we graphed the original quadratic, it would cross at the x-intercept at negative 1 and at positive 5 thirds. Example number 2 is done the same way. We end up having y equals 5x squared minus 18x plus 9. We change the y to a 0 because we want to find out where this quadratic crosses the x-axis. And then we're going to go ahead and factor it. So we use my diamond. You go 5 times 9 is 45. And we want that to add up to a negative 18. My factors of 45, there's 1 and 45, 3 and 15, and 5 and 9. For this, I need 3 and 15 because they add up to 18. But we have a negative 18. And to get it to be a negative 18, both of these need to be negative. So a negative 3 and a negative 15. Then we are going to factor by grouping again. So remember that this middle term are really these two pieces here. So a negative 3x and a negative 15x. And then I'm going to keep my plus 9 and my 5x squared. We go ahead and break it into 2 sets. And because there's a negative there, we put a plus sign there. Okay, so now we have 5x squared minus 3x. The only thing that those have in common is indeed an x. So I'm going to go ahead and pull out an x. 5x squared divided by x, we're left with 5x. And negative 3x divided by x, we're left with a negative 3. And then for the second set, we have a negative 15x and a positive 9x. So looking at this, they have a 3 in common, so I'm going to bring out a 3. So negative 15 divided by 3 is a negative 5x, and a 9 divided by 3 is a positive 3. Remember that these have to be the same thing. They're not quite the same thing yet. In order to get this to be the same thing, we need to take out a negative. So we should divide it out by a negative 1. So that's now a negative 3 outside. That becomes a positive, and that becomes a negative. So now we have 5x minus 3. So my two factors are 5x minus 3 and x minus 3. And we set each of those equal to 0 in order to get our answer. So I'm going to take 0 equaling to 5x minus 3 and 0 equals x minus 3, and I'm going to solve that for x in both cases. So in the first case, I need to add 3 to both sides. So 3 equals 5x, and I need to divide by 5. So I'm left with x equals 3/5. And in this case, I just have to add 3 to both sides. So I get 3 equals x. So this would cross the x-intercept at 3/5 or 3. Not or 3, and 3. Let's recap our steps. So the first thing you have to do is you have to change y to 0. And you do that in order to find where it would cross the x-axis and to use the zero product property. Step 2 is you factor the quadratic. You can factor the quadratic using any method. Step 3, you take each factor and set it to 0. You do this because anything times 0 is going to give you 0. And when you do that, you will find where it crosses the x-axis. And lastly, you solve for the variable. Now it's your turn to try one. The first one is y equals 6x squared minus 20x minus 16. And number 2 is y equals 9x squared plus 12x plus 4.